Okay, and hello, I returned to this project in these drawings because when that beam changed to a steel beam and I modified these drawings and the floor framing changed, I only had modified them so far as beam A went and its related things. And I wanted to return to the drawings and double check all the rest of it and see exactly how, and I also wanted to explain how I thought the beam C, which support is over the dining room and living room, how that was going to interface with this beam A. So I wanted to be sure to explain that, what I thought was going to happen. And in the course of that, several other things happened, but I double checked all the relevant members to get to this point. And first of all, this is the steel beam. This is how I had it drawn, but it's obviously going to come down that 3/8, I would think, underneath that subfloor, that 1x subfloor up there. And I don't know if that's glued there or if there's any kind of, fasteners put through there. That's how I have it. Drop that 3/8. That means you'll just have to add a layer of 3/8 drywall on either side of it before your 1/2 inch covers it. And then those 3 members that Carl has shown in there, those come down as well with the beam. And those are bolted through the beam like that at 16 inches on center. Carl drew this, those joists were running this way, so I don't know if he's going to modify that. But that's what's shown right now, shown on the drawings dated October 3rd. And those are going to change because there's some things on there that are errors, more or less, or that need to be corrected to reflect what's currently happening. Additionally, there's issues with the plumbing that I want to at least take a look at and see what you thought or we thought was going to be done in terms of that plumbing. Not to keep this too long, there is beam B, the LVLs, underneath that. And I believe the 10-3 drawings, the October 3rd drawings, are still showing that as 4 LVLs. When in fact, when this gets retested, this isn't going to take 4 anymore. Beam A requires 5 1/4 inches of bearing on this LVL. So we can get by with 3 of these probably. But I went back and checked all that. Right now, if they do indeed have these 97 1/8 inch standard height walls, with these LVLs in here, this is the clearance underneath, 84. You can see that pretty much allow you to align your casings through there. And there's not really an opportunity to put any kind of continuous plate here because of this drop down beam. So I just left it like that. I mean, I had horsed around with lowering it and putting a header on top of it or a wall plate on top of it across here. You could do that and it would just lower it 1.5 inches, but if you wanted to integrate that, you would have to lower it all the way to here. You'd have to lower it another 2.5 inches if you wanted to bring a wall plate continuous across there and not underneath beam A. As it is, I'm leaving it like that in the drawings. But as I said, I went back and rechecked all the members that were relevant, which was beam A, and this was the spans and the supports and the loads coming down on beam A, what Carl specified, the 10x39, and that passes, and this is the reactions at the end of that, this 8410 coming down on beam B. And then I redid beam B the same way, double checked all these loads where they're coming, and before it was taking 4 of these, but now with this reduced load, 3 of those does the job. And the reaction now on this, on beam B at each end, are these numbers here. So those footings are probably going to be adjusted because that 7691 is only requiring 27-inch footing and the other one's an 18-inch footing. So I went back to these foundation drawings and redrew those with that smaller size, with that less load. And I also thought I better double check beam M here, which is picking up this, or right now, this beam G. More on that later. So I double checked beam M as well. Brought that load from G down on it. 2 of those LVLs passes, and this is the loads to their supports, which reduces those as well. And so this basement plan down here is also modified and downsized. You will have to confirm there's some sort of header over here carrying that over to each side, and that should be fine. And then this here for that littler, for the load on the right end. That returns us to this. Some of this was done earlier before I recognized that 5 1/4 is enough bearing for that steel beam. So I was endeavoring to get a wall plate on top of that, a 5 1/2 inch wall plate. And we could just leave it on there for now. And this is typical boilerplate, but this is how beam C integrates. Beam A comes all the way to the outer edge of that for that full 5 1/4 inch bearing. Those 3 members that are bolted to the inside just come halfway on the wall. And then beam C ends up with 2 3/4 inch bearing and is integrated into that, and you could just notch this top piece where it comes under the steel here, or the bottom piece, either one. And those 3 are put in like that, so they're practically in line. And then, you know, shims are tightened up in there. Everything's tight where that meets. Then when I started looking at this section, I felt like beam C, I wanted that underneath the exterior partition at the back of bedroom 4. And so at first I had just shifted this beam wantonly out, but I feel like Carl wanted that center line of the beam underneath the center line of the wall. So I reverted and pulled that back where it's shown on these plans, and I moved beam C then out, still integrating it with the steel beam A, but you have to put a piece of 3/8 OSB between these, and if they're calling for 10s, we'll just increase the nail size to 12s through those 2 members there. And so that's beam A and beam C, so that over here on this end, beam C is like this. I'm assuming that gets pushed up against the underside of that subfloor. So you will just have to notch the top of it where it integrates with that steel beam. And just to be thorough, I double checked notching that to 8 7/8 high, and the 3 of them still pass. So that is what I'll be showing right now as far as all these beams go. At the risk of being exhaustively repetitive, one last comment with regard to this beam B. And I showed it here with the wall plate above it. And either way, somewhere along the line, I'm not sure exactly where these heads of these windows are now, whether it's at 6/11 3/8 or something closer to 7/0. But that should be adjusted so that everything can be aligned through there. Hopefully that can happen. There's a good 1.5 inches of space here. So I think it can happen, but that's all on that. And this arrives us at back here, except this is shown a little different. This is before I just did that right now, discovered that that was going to have to move out. But in any event, it remains the same. Those joists back there, those lookout joists tie into that, and those lookout joists continue across the kitchen that way, like this. And then I built this plumbing just to see, or enough of it that I could see what was happening. Now, I do know very little about plumbing, but one of the things I saw right away was where this 2-inch, looks like a 2-inch pipe or 1.5 inch pipe penetrates this beam this beam G that we installed, this 4-ply beam G that was right in here. So I split that into two 2-ply beams with a maximum 14.5 inch space between them to do whatever you have to do. And it looks to me like that pipe continues on up into the wall. And this one I think goes both ways. So I tested this beam with that, and I made this, assuming this is 2 3/8 outside diameter, 2-inch pipe, I made these holes 2.5 and centered vertically in that member right here, and that passed. And I thought sure that this would never pass here at all. But we're pretty sure that the plumbing's got to go that way and then go down and then back across the ceiling and into the drain. And you can see there's not much space right there. But here is that bit going up into the wall with these members here, one GA and one GB. And as I said, I don't know much about plumbing, and there's a lot that's not even shown here, but I'm assuming the idea is that we're going to go down in that wall there. Make it big enough that we can go down in that wall there. And I think I mentioned I didn't think these would ever pass with this 3 3/4 inch outside diameter hole through these members. But I went ahead and ran the test on that because I thought we were going to have to take everything this way down toward the refrigerator and then down, because I didn't think we were going to be able to penetrate that. But I added those holes into the calculations, 3 3/4 on the outside, vertically centered, and that passes as well with 2 of those 9 1/4 LVLs. So you can have it continue that way, put it together that way. And then going down that way, I presume you can get your whole slope from here down to there. This is one stack here with the toilet. And I don't know how you're going to put this together. As I said, I don't know anything about plumbing. But I do know we got to get down to the basement. And it looks like a close call on that wall plate down there. You can see it's pretty close here. And I don't know what, this is kind of a guess here. But if it's put like this with this 1/4 inch per slope from the top of that wall plate, and I don't know that that's possible, and gone up, then that puts that 3.5 inch hole a little bit higher in this member. But it's still passed if we put it up 5 3/4 of an inch, the 3 3/4 hole. Okay, and so assuming that works, assuming everything south of this wall works, and our challenge then is to get this to the basement, there were really only 2 choices, and I'm sure you guys have arrived at that, because that's how tight it is right now. So the choices are to make that doorway smaller, like this, and that brings it down from 9.3 to a little over 8 feet. So it comes down about 15 or 16 inches. And that really, maybe that creates somewhere between 10.5 and 11 inch space up here. And I don't know if that's enough. So, and that's coming small like that. But the alternative to doing that is, as you know, thickening this wall. And I'm just showing it thickened by 4 inches, which should be enough, because you'll have, if you got that 4 inches, you'll have all this space here to work with. So that gives you plenty of the 4 inches. So probably that's the easier thing. If you do make this door smaller, you got to move those bottom footings over, and probably they might, that might even change the calculations on this beam here if you make it smaller. But if you decide to go thicker instead, and I make it's 10.5 inches total now. So that was from this end, this was the wide door. This was making that door skinnier. and then this was making that wall thicker instead, like this. And then the only other consideration with regard to that, if you do this, thickening this wall this way, like this, is the positioning of these windows here and what happens along that wall. So I don't know if you recall, but this window here was centered on that patio covering outside. And this was probably symmetrical from that wall before I started horsing around with it. But if we assume we leave this centered under the peak outside, and this puts it, and then if we make it even like this, the 2'1" on each side, that kind of starts pushing it back behind the refrigerator. And my feeling is that it does not hurt that to just come out as far as you want, really. I'm just showing it coming out 5 more inches than this one is to get it out here where people are actually looking out, that isn't buried back in that corner. And that does not hurt us outside at all, really. It probably is even better. So I almost prefer that. I almost prefer this thickened wall as a solution. But presumably they're going to need these plans updated at some point. So hopefully this covers enough that you'll be able to put the things together the rest of the way. But definitely let me know what I should do. All right, thank you very much, and I'll talk to you next time.